5.1b in Advanced Algebra 2, just kind of continuing on what we did last time with the exponents and all that stuff. We just throw in negative exponents today. And on these three warm-ups before we even get to our practice problems, I'll show you what you're really supposed to do with negative exponents. If an exponent is negative, that means you take the base and reciprocate it. What does that mean? Reciprocate. I told you to reciprocate something. What that means? Flip it over, right? So what's the reciprocal of x when it's really x over 1? What's the reciprocal of x? It's 1 over x. And then all that does when you reciprocate the base is it makes this exponent, which was negative, it now becomes positive. Sorry, my pen froze. It becomes positive, right? All the negative part of the exponent means is please reciprocate the base. Then you'd square each thing, and you'd get 1 squared is 1, and x squared is x squared, and that'd be your final answer right there. If I did it here, I've got a negative exponent. I'd reciprocate the base, and now the exponent is a positive 3 instead of a negative 3. Then you cube each thing. 1 cubed is, and x cubed is x cubed. And that wasn't too bad, but look at the nightmare that's about to show up here on the next one. The thing that people don't understand is what's being raised to the negative 7th power. Is it the 2x, or is it just the x? What's being? It's just the x. Because if they wanted the 2x to be raised to the negative 7th power, it'd all be in parentheses like that, which it wasn't. So 2 does not get affected. The x, though, since it has a negative exponent on it, you have to reciprocate that base and raise that to the positive 7th power. And then each one of these, the 2 is still there. You'd get times 1 over x to the 7th. And then you'd have to multiply these fractions together. So you turn him into a fraction, you get 2 over x to the 7th. Just way too much work is what that really is. It's way, way, way too much work. If you realize there's a little thing called the change of house game. When you have a fraction, there are two houses, in my opinion, the numerator and the denominator, or I call them upstairs and downstairs. And if you have a negative exponent, wherever it's at, he will change houses. For example, if I do this problem over again, this problem was x to the negative 2nd. Well, as a fraction, isn't it really that? Correct? This guy has a negative exponent. He needs to switch houses. He's upstairs right now. He has to come downstairs. And when you change houses, his exponent will become positive. So you start over with a fraction bar. He's moving, and he'll become positive. And a lot of people put nothing upstairs again. There has to be something up there. What's really up there? The 1. So the old change of house game. And what we've got on all these examples is we've got 3 different scenarios that will show up today. We'll just go through them one at a time as we kind of come across them. But in the first one, I want you to realize this. Do you have any fractions? No. Do you have any quantities? You know, like where the whole thing is raised to a power or anything like that? Is there any of that going on? It's just stuff that needs to be multiplied together. Even though there's negative exponents, we'll deal with those later. Let's clean it up. Numbers times numbers. Get it done. Coefficients multiply together to be 8. Correct? R's. R to the negative 3rd times R to the positive 2nd. What do I do with those exponents again? Add them, and how much do I get? R to the negative 1st. So I've multiplied them together. But now I have a bad thing, because I have negative exponents in here. You can't have a final answer for it to be proper with negative exponents. So I say, let's play the change of house game. I start with a fraction bar when I do that. And let me ask you about the 8. Is 8 good or bad? Does 8 have a negative exponent on him? 8's fine, right? 8 stays where he's at, so he's upstairs. The R to the negative 1, he's got a negative exponent. Isn't he upstairs already? He needs to change houses and come downstairs. And it would be R to the positive 1, but you don't need to put the first power. Cool with that? So that one had no fractions involved with it, but we still ended up kind of turning it into a fraction due to the fact that it had negative exponents. The next guy, he's already a fraction. Same rules as before. Look at coefficients first. There are none. Start with a fraction bar. That's the best advice I can give you. Start with a fraction bar. And then ask yourself this question. Are there any negative exponents involved? Yeah. So look at x's first. This guy, doesn't he need to move houses? He's upstairs. Wouldn't he have to come downstairs, right? But how about this guy? Is this a negative exponent or not a negative exponent? So he's cool where he's at, but he has to move, correct? So if two x's are coming downstairs, and there's already 4 x's down there, how many x's will totally be downstairs then? X to the 6. I'll say that again. There were already 4 downstairs. 2 more had to come down, right? So now there are 6 total down there. When it comes to the y's, this old boy, he's cool where he's at because he has a positive exponent. Doesn't this guy need to move, right? So since he's downstairs, he will come upstairs. And isn't there already 1 y up there? And if you bring 1 more up, how many do you have? You have 2 of them. Cool. Let's try another one like that. On number 3, are there coefficients involved? So let's start with a fraction bar and simplify those coefficients. 4 over 2 is 2 over 1. X's, there's some up, some down. I also kind of cross things out after I've dealt with them. You'll see as things get messier, that's a nice little handy thing. This x to the 5th, isn't he good where he's at because he's got a positive exponent? And this x to the negative 3rd, he needs to come upstairs, right? He's got to change houses. So how many total x's will I have upstairs? 8 of them. Done and done. When it comes to the y's, are there any negative exponents at all when it comes to y's? So then you just play where are there more? And where are there more y's? Downstairs. 2 more. Cool. One thing at a time. Number 4 has no fractions dealing with it at all. Multiply all that stuff together for me. Don't worry about the negative exponents at all. Just multiply it all together for right now. And hopefully you got 12a to the negative 1, b to the negative 1, correct? As a fraction, it's really this. So let's see who needs to stay and who needs to move. I'll start my final answer with a fraction bar. 12, stay or move. 12 stays. A to the negative 1, stay or move. Moves downstairs, becomes a to the positive 1, and b to the negative 1 also has to move, and it goes down there. And this one stayed. Nice? Let's see what's next. Here's the ones that hurt people. There are no fractions involved in number 5, but you have a quantity raised to a negative exponent, right? This is a different scenario, total new idea. First thing, of course, look inside, see if there's anything you can clean up. Is there anything you can clean up? No. When the entire group is raised to a negative exponent, I feel the easiest way to succeed is to use the real rules of negative exponents, which mean reciprocate the base. If there is a negative exponent, you should reciprocate the base. In this case, the base is 2x squared over 1, right? What is the reciprocal of that going to be? 1 over 2x squared. Then keep that in parentheses, and all you've done is use the negative exponent. It will now be raised to the positive 4th power. I'm not saying this is the only way to do it. I'm saying this is the easiest way to understand it, because taking stuff to a negative exponent, especially coefficients, is a pain in the butt for a lot of people. But taking stuff to a positive exponent, you're pretty good at, right? So I wanted that exponent to be positive, so I reciprocated the base. Now every nugget in there needs to get raised to the 4th power. So 1 to the 4th power is 1. 2 to the 4th power, 16. And x squared to the 4th, add or multiply those exponents together. Multiply and get x to the 8th. Cool? So when you have an entire quantity raised to a negative exponent, the best idea, reciprocate the base. We have that. Again, I have an entire quantity raised to a negative exponent. Can anything inside clean up, though, before I get started? No. So reciprocate this base. It would be 1 over 3x to the 5th y squared. And the exponent on the outside now goes from a negative 2 to a positive 2. All the negative part meant was reciprocate the base. Now, square everything in there. Cool. Off to the right where you got a little room in the margin, I'll make one more up for you to try on your own here. Try this one. 7x to the 4th, y to the 3rd to the negative 2nd. Negative exponent outside of quantity, nothing to clean up in here. I'm reciprocating first. Positive second power. Then 1 squared is 1, 7 squared is 49, x to the 4th squared is x to the 8th, and y cubed squared is y to the 6th. Rock and roll. Next. Same thing. All right. Didn't realize I had that one in there at all. It's got a negative exponent on the outside. I will reciprocate the base, and then it would be raised to the positive first power, which, ta-da, then we're done, right? Because everything to the first power will be itself again. Cool. 8. Two different things about it. Number 1, ding, 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 not a negative exponent. That's a positive exponent. We're in shape with that. Number 2, can anything clean up inside of there before we even get started? What is that? X to the negative 2nd times x to the negative 3rd. Will it be x to the negative 6th, x to the positive 6th, or x to the negative 5th? You add those exponents together and get x to the negative 5th. That is being raised to the 4th power. Cool? Now you can use your cool little trick if you want to. Since this 4 out here is positive, you can just multiply these exponents and get what? X to the negative 20th. Is that a good final answer? No, because it's got a negative exponent. This guy is really upstairs, so he needs to change houses and come downstairs. X to the 20th down, and what's upstairs? 1. Righteous? I know a lot of you have done this before. It's just a memory refresher, especially if you've had me. That change of house game is not a new thing to you. Now, combo. We got all kinds of things that need to happen. In this guy, you've got some exponents outside of parentheses, and you've also got some multiplication. According to the order of operation, what should you do first, exponents or multiplication? Exponents. So I need to do this first. I've got a negative exponent on the outside. Even though the coefficient of this is 1, I still suggest to just get in the habit of saying, all right, if that's a negative exponent outside, you should reciprocate the base. What is the reciprocal of x to the 4th? 1 over x to the 4th. And now it will be raised to the positive 3rd power. And this times 2x to the 4th just comes on down for the ride. It's not the only way to get this done. Like, you've got to understand, there's a bunch of ways to do these problems. I'm trying to give you the most consistent way in every scenario. If that's a negative guy out here, I advise you to reciprocate the base. Now you cube each one of these. 1 cubed. And x to the 4th cubed is x to the 12th. Then you got to take it times 2x to the 4th. I will make that a fraction real quick so I can multiply them together. And that is really 2x to the 4th over x to the 12th. In that answer, there are no negative exponents. So we're in good shape there. Is it as simple as it could possibly be, though? Now you got x's up and x's down. Where are there more x's? Down. So 2 still upstairs, and there are 8 more downstairs. Please realize that's not the only way to get to this answer. If you get there, you are in good shape, right? So there are many other ways to get that done. Try 10 for me, please. Pause the video, give that a shot. Nice. Negative exponent on the outside, reciprocate that base, bring everything else down. Take everything to the fourth power, bring this guy down, turn him into a fraction so you can multiply them together, and you get this. Then the only thing that cleans up 5/16 cannot reduce, but there are more x's downstairs. Cool? Yeah. Woo! We do have a quantity to a negative exponent. But before we reciprocate the base, we look inside and see if anything can clean up. So I'm going to start with a big old parenthesis. And yes, stuff can clean up because there's a's up and down, there's b's up and down. So I'm going to clean that up first. And I start with a fraction bar, and I'm going to keep that -1 as an exponent on the outside. Coefficients, there are none. A's up, he's cool where he's at. This has a negative exponent on it. He should change houses. So how many a's will I have upstairs? A to the 5th. B's, no negative exponents. More b's down, 1 more b down. Correct? So that's just cleaning up the inside. Now I will use the negative part of my exponent right here, which means reciprocate the base. So wouldn't I get b over a to the 5th? And that would be raised to the positive first power, and that means I'm done. Cool? So let's do that on this one. First, clean up what's inside. Start with a fraction bar and clean that up. Three was cool where he was at. A's to the 7th is fine where he's at. A to the -2 had to come up, so there's now a total of 9 a's upstairs. And there are 5 more b's downstairs. All of that is raised to the -2nd power. Then use the negative. Ba-bing! Reciprocate the base. And it is now being raised to the positive 2nd power. So now you've got to square everything. B to the 5th squared is b to the 10th. 3 squared is the 9, and a squared is, a to the 9th squared is a to the 18th. Groovies? Sweet. Negative or positive exponent on the outside? Positive. Get her done. Get her done. Take everything to the 3rd power if there's nothing to clean up on the inside. The thing that messed some people up last year was the negative coefficients. Right? -2 cubed is -8. Then b to the -2nd cubed is b to the -6th, and c cubed cubed is c to the 9th. That is not a good final answer, though, because I have negative exponents. So I start with a fraction bar, and let me ask you about him. Does -8 have a negative exponent on it? No. It stays where it's at. It's just a negative number. It does not have a negative exponent on it. It does not change houses. B to the -6 does have to move, and c to the 9th stays where he was at. Cool. Negative coefficients don't change houses. Only negative exponents do. 14. This is a positive exponent, so everything's just going to get cubed for me. There's no fractions involved, nothing to really clean up in here. So I got -125, x to the 15th, y to the -9th. Correct? Then change in houses. Negative 125 stays, x to the 15 stays, y to the negative 9th moves. It becomes y to the positive 9th downtown. Cool. 15. All kinds of exponents, all kinds of parentheses, all kinds of stuff. Do you have any exponents outside of the quantity, though? No. They're all inside the quantity. Realize I didn't put a space here. My bad. This should just have a space. So this is 4j times this times that. Multiply it all together. Coefficients times coefficients. J's times j's. K's times k's. So let's see how we did before we clean it up. Coefficients. Obviously, he's a coefficient. He's a coefficient. Are there any other coefficients in here? The answer is yes. Where is there another coefficient? There's a negative 1 right there also. So when you multiply them all together, 4 times negative 1 times 3 is negative 12. You got to be careful with that negative 1 right there. J's, you got j to the first times j to the negative second times j to the third. Well, one at a time. This is j to the negative first times j to the third, which is j squared. Is that right? Yes, no, maybe. Adding all these exponents together. 1 minus 2 plus 3. K's, k to the negative fifth. Right? Now cleanup time. Negative 12 stay or move? It stays, because it's just a negative coefficient. The only thing that moves are those k's. You and pal, attempt 16. Talk yourself through it. What would you do on 16? Talk yourself through it. If I do this different than you, it doesn't mean that you're wrong. Let's check our final answers and see how we get, because there's lots of ways to get there. I feel the easiest thing to do is simplify what's in the parentheses first. 8 over 4, 2 over 1. M's, 2 more upstairs. N's, 1 more downstairs. It's all still being raised to the negative first power. Still not good. I got to take it to the negative first, which means reciprocate the base. N over 2m squared, all to the positive first power, which would mean I am finished. If you got here, we're in good shape, because there's other things that people could do. Some people reciprocate it first and then simplify. Some people, there's just a lot of different things that you could do. This, in my opinion, is the simplest. And now for the mess. It's not that bad if you go one little nugget at a time, but there's a trick in here that I want to show you that's a lot easier. Check out, do you have any groups raised to an exponent at all? Do you have any? This is a group, and it's being raised to the negative second power. Let me ask you about that group, since it's raised to the negative second power. Will that group stay upstairs or move downstairs when it's raised to the negative second power? It's going to move downstairs. So we're going to start this fraction problem with a fraction bar. And I'm going to go every little nugget at a time and see if it should stay or move. But I'm going to treat that group as a giant nugget. So start here with 2. I don't care about simplifying yet. I'm going to get everybody in the right place. 2. Does he stay or move? Stays. Then I cross him out to realize I've used him. M stays, right? N to the negative second, stay or move. So I'm moving him down, and he will now be n to the positive second. Then I cross him out. Now here's my big nugget of a group. Does that group stay or move? So the whole group, I'm just keeping it the same in there, that 3m to the negative second n. I'm not changing that at all. All I'm changing is this negative 2 is now a positive 2 for an exponent. You with me on that? Then I cross him out. I've used that group. I still have all of this stuff down here. 12, stay or move. 12 stays. So he is downstairs, right? I'm going to put him downstairs. Since he's a number, a coefficient, I like to put them in front. It doesn't mean you can't have it in the back. Right? You can have it there, but I like to see my coefficients in the front. Okay? M to the negative third, stay or move. So he's coming up, and I'm just going to put him. N to the negative fourth has got to move, and I'm just going to put him as n to the positive fourth. I didn't worry about simplifying anything in that step. I just moved things where they were supposed to go. Cool? Now I'm going to deal with this, because according to the order of operations, that's my next maneuver. I should square all of that stuff. So I'll do a little bit of cleanup. I'm not going to clean up my coefficients yet, just because I got some others coming along. But upstairs, I'm going to call that 2m to the fourth n to the fourth, because don't you have those amount of m's right there? Nice. Down here, I'm still going to have my 12n squared. Sorry, my pen freaked out. 12n squared. And I now am going to just square all of this stuff. The 3 has to get squared, and it would become a 9. The m to the negative second has to get raised to the positive second, and that would become m to the negative fourth. Right? And n to the first squared would be n squared. Dang it. Sorry for my pen problem. Sweet. More cleanup needs to happen. This old boy got to come up. So I'm going to just keep on rolling down with a fraction bar. I got a 2 upstairs. I've used him. Cross him out again. I'm bringing 4 m's up. Right? I'm bringing 4 m's up, and there are already 4 m's up there. So how many m's are going to be up there? M to the 8th. Cross both nuggets out. I brought him up, and I used him. N to the 4th. Downstairs, I have a 12 and a 9 for coefficients. Grab ye old calculator and punch that in. 12 times 9. Help me out with that, I don't know. 108, is that right? 108, thank you. Done with you, done with you. Downstairs, I got n squared and another n squared. Isn't that a total of n to the 4th? What? This is an m or an n? What is this? N or m? N as in Nicholas? All right, okay, so we all cool? Then final cleanup, right? Everything's positive exponents. Reduce your coefficients, reduce your m's, reduce your n's. Fraction bar coefficients, 2 over 108 can reduce, right? What's that reduce to? 1 over 54. M's, there are only m's upstairs. N's, I got the same amount up and down. They divide out to be 1. That is a mess. There is no doubt about it. There is probably no way that you stand a chance to get that done in like one move. The better you get at it, you don't have to necessarily have 1, 2, 3, 4 different steps, but that's the way I suggest it. So let's do that again on this nasty problem. Let's start with a fraction bar. Let me put this in a new window so I got room for it. And what I really notice is this group again. The whole group is raised to a negative exponent. So move everything that needs to be moved and keep everything that needs to be kept. 4 stays. X stays. Keep rolling. And check yours with mine. How we feel about that part? Just keeping putting everybody where they belong. Next thing, some cleanup, and also take that group to the third power. So my cleanup upstairs, I got 4x to the 8th upstairs. Used it all. I got 3 downstairs. I got y to the 9th. See how I cleaned that up right away? My y to the 9th. I used these two right away. There's my y to the 9th. And then I'm going to get a 4 cubed is 64, right? Right? Okay. And x to the 6th, y to the 3rd. Then final cleanup, I should say final cleanup, but another cleanup. 4x to the 8th. Need a calculator. So I'm going to do 4 over 192 in my calculator. 4 divided by 192. Hit math enter, enter. See if that's simplified to 1/48. X's, there's 2 more up. And Y's, there are 12 down. Again, it doesn't matter how you got there. Our paths could be different. Like, no, I'd rather do this and this and this. I understand this better. You know, it's all cool. Get here, and we'll be good. Right? Get that answer. So another one like that. There's one small difference between the previous two and this one. What's the small difference? The group will not be moving, right? Doesn't he stay upstairs? So please pause the video. Give this one a shot. For all you out there in video land, it doesn't really matter to me how you got there as long as you got here. All right, check your final answer with mine because I did some stuff at the same time. I kept the 7, I kept the A, I moved the B. Since I knew this brother was staying, I went ahead and did it right away. You know, it's like that's just once you get more comfortable with it, it's like I know it's staying there. Why rewrite it when I just have to do that next? You know, that's your next move. So I took all that stuff to the 4th. A to the 8th came up, and B to the 5th stayed. Then you just multiply. This old boy had to come down also. Yep, last one of these. Simple one for you. Do it, check with pal. Talk out with pal, whatever. Work with pal. Again, it doesn't matter how you get there. Just get there. But this is what I would do. First, I see, ooh, negative exponent. But even before I see that, in here, stuff can clean up. 2 stays, x to the 4th stays. This guy comes down. I clean that up first, personally. It's not something you have to do, though. But I want to put him down where he belongs. Now, I'll use the negative exponent, and I will reciprocate the base. And now that's all raised to the positive 3rd power. And then you get y to the 9th over 8x to the 12th. If you have this, we're okay, right? It doesn't matter how you get there, because some of you that didn't bring that down right away, you'd have had a y to the negative 9th down here, and then you had to move him upstairs, and it's still all good in the neighborhood. Cool? So fun details. Let's do something simple. Finally, let's do this right this time. Combining like terms, adding and subtracting polynomials. When you want to subtract this polynomial away, though, what do you really have to do to this polynomial? Distribute this -1, which changes all the signs. I feel it is better. We used to just change the signs in there. I think you should rewrite the whole thing. Everything in there, sign should change. It doesn't mean they're all negative. In this case, they are. But you just change all the signs. And then you combine like terms. Notice this, though. Isn't the only variable involved an x? Right? There's no more y's, there's no z's, no w's. There's just x's involved. Sure, some of them are squared, but they're x's. Put them in standard form. Highest degree to lowest degree. So that would be the squareds first. If you have 6x squared minus 4x squared, that is 2x squared. X is next, -4x's. and constants last. 2 minus 3 is negative 1. This is called standard form because it went from highest degree. This is degree 2, this is degree 1, this is degree 0, right? That's the order they should go in when it's only one base. Next one, no. First question, do I have to change all the signs in the second dude? Nope. But aren't there x's involved and y's involved? There is no proper order to put them in, right? There's not just one way to do it. So the way I roll with it is I read from left to right. Here's some y squareds. I'm going to find all my y squareds first. 7y squareds. Here's some more y squareds. That would give me 3 y squareds. Cool? Cross them out is what I like to do. xy's come next. So here's some xy's. There's some xy's. That is 18 xy's. And x squareds are last, negative 8x squareds. One other thing, for those of you who I've noticed are very color-orientated, like me, a color person, when you do your homework on OneNote, it really makes a cool difference if you do your like terms in different colors. I don't know, that's just the way I roll. I'm a color person. I'm not saying you have to, but it's a lot easier to see, for me at least. Cool. No right order to put them in. Next one. Do you need to change all the signs in the second quantity? Do it. Only m's are involved. Put them in standard form. Only m. So that would be negative 8m squared minus 12m. Cool? Do you understand what we're doing when we are combining like terms? You all right with that? Let us move to the, oh wait, one more, 17. People look at that and get really scared. They're like, oh my God. They do know that they need to get a common denominator to add stuff together, but don't overwork yourself. Find your like terms first, and then see what you need for a common denominator. So like, first of all, different variables. You got x's and y's, so I'm going to read from left to right. Here's some x squareds. Find the other x squareds right here. One has a denominator of 4, the other one has a denominator of 8. What do I need for a common denominator? 8. So change this guy into eighths. This would need to be multiplied by 2, right? So isn't that really 2 eighths x squared? And if you had 2 eighths x squared minus 3 eighths x squared, how many total eighths is that? 2 eighths minus 3 eighths. Negative 1/8 x squared. Done with them, done with them. All I did was add my x squareds together. Next, guys, are xy's. Here's some xy's. Here's some xy's. One has a denominator of 2, one has a denominator of 8. What would I need? I need eighths. Be very, very careful, though. This would not be 4 eighths. It would be negative 4 eighths, because that was a negative 1/2. Negative 3 eighths and negative 4 eighths is how many total eighths? Negative 7 eighths xy. And then finally, the y squareds come next. Denominator of 2, denominator of a 4. Ha-ha! All you need is the denominator of a 4 right here. So this would be 2/4 y squared plus 1/4, which is 3/4 y squared. A lot of people would say go change all those to eighths right away. You didn't need to do that. Look at the like terms and see what they have to be, because if you change them all to eighths, this would have been 6 eighths, and you would have had to reduce it anyway to 3/4. So just go like terms at a time, and it'll roll with you. Nice? Yay! Please tell me what we will do here to take 2x times that binomial. What's it called? Distribute. But it's been a while. Same concept, numbers times numbers. 2 times 3 is 6, but then you got to take x's times x's. X squared times x is x to the 3rd. Nice? Then you take 2x times negative 5 and get negative 10x. That is in standard form also. Nothing but x's, highest degree to lowest degree. Distribute the next one. Be careful with your exponents. That's the hardest part about these. It's not a complicated concept. It's just, oh, missed an exponent there. If you have this, not good enough. What's wrong with it? Not in standard form. Only A's are involved, so rearrange it. Cool. Hey, what's a GCF between all of these? What's a GCF? Just 7? It's right here. GCF is the reverse distributive property, right? If you undistribute, wouldn't 7a come out of each one of those terms? Please tell me you understand the distributive property. Well, if you understand the distributive property, then the next things are a piece of cake. This used to be a hard thing for students because we're taking a binomial times a trinomial. Do you FOIL that? Only thing you FOIL is a binomial times a binomial. But check this out, folks. It's just the distributive property is all you have to do. If you pretended that that wasn't there for a second, can you take x times every single one of those guys? Yes or no? Do that. That would give you 2x cubed minus 3x squared plus 1x. Right? Then you just say, well, hey, there's also a plus 1 there. Now you need to take that plus 1 and distribute it to every single one of those guys also. So 1 times 2x squared is 2x squared minus 3x plus 1. All you do is look at the first guy, which was x, and distribute it here in blue to every term in that guy. Then you take 1 times every single thing over there, and you get this. Notice this. You took 2 dudes times 3 dudes. How many dudes should you get back? 2 times 3 is 6. I got 6 guys back. Now combine like terms. So, standard form, cubes first, squareds, x's, and constants. Done. One guy at a time. So, let's do that again. Forget about him for a second, and again, if you were using colors on your OneNote, I do these 3 guys in one color. Right? Take 2n squared times each one of those puppies. Watch your exponents. Then I pick a different color, and I take not 3 times all of those guys, but what? Negative 3. Two dudes times 3 dudes should give you back 6 dudes. There they are. Now you check for like terms, and there are like terms. Sweet. Now I'll show you a little something that you may or may not have seen. Do we feel comfortable with this process? Well, check this out. Binomial times a binomial. You're supposed to FOIL that, right? Well, check it out. When you FOIL it, you'd go this guy times this guy, right? Then this guy times this guy. Then this guy times this guy. Then this guy times this guy. Isn't that the same thinking thing that we did? We covered this dude up and said take 2x times every dude in there. First terms times each other. Last terms times each other. Then you'd move whatever the heck this was out of the way and take it. Inside guys times each other. And last terms times each other. I should have said outside when I said last earlier before. but then you combine your like terms. That's all FOIL is the distributive property. But back in Algebra 1, many brains can't handle that, so they came up with that acronym. Well, you take the first times each other, then the outside times each other, then the inside times each other, then the last one times each other. It's just the distributive property. Sweet. Let's work on homework.